Hello students, in this video we are going to look at some graphs of proportional relationships. We're not going to be graphing them. This lesson is called graphing, but we're looking at graphs and determining some things from those graphs. So I have a few problems that we're going to look at together, and we're going to talk about some of the vocabulary words that we've been discussing so far. So here's a graph of a proportional relationship, and I actually think the next video almost should come before this one, because to determine whether something is a proportional relationship, there are a couple things you need to look at. One of them is it has to be a straight line. So all of these are going to be straight lines, and they are going to go through the origin, which is right here at 0, 0. That's the origin. So let's look at this particular problem here. It says the Crafty Clay Art Show has invited Lindsay to make and sell her famous decorative plates. She molds the plates out of the clay and then paints them. This graph shows a proportional relationship between the number of plates she makes, x, which is this down here at the bottom, the number of plates she makes, and the amount of clay she uses in pounds, which is our y-axis right here. So as we can see, there is a point on here that's marked, and that is 4, 8. And this is when x is 4, y is 8. And if you remember, they already told us that x equals the number of plates, and y equals how many pounds of clay she uses. Okay, but I want to look at a couple other things before we look at this problem in particular, because they're just asking us, what does 4, 8 represent? You remember we talked about the term constant of proportionality, and we looked at some tables and things like that in some previous videos. If you look at this graph, constant of proportionality, when it comes to looking at a graph, what this is asking us is, when x equals 1, on silent, I did now, when x equals 1, what does y equal? That is the constant of proportionality. Remember, it's also the unit rate. So we want to find out what is y when x equals 1. So to find the constant of proportionality on this particular graph, I'm going to change colors here. I need to go over to x equals 1 and then follow that line up to where it intersects with our line, our green line here. Okay, so when x equals 1, what does y equal? Y equals 2. So in this case, our constant of proportionality would be 2, because y equals 2 when x equals 1. So I just wanted to show you that on this graph. But what this is asking us is, what does the 4, 8 represent? Okay, let me grab a different color again. So the 4, 8 right here, you notice that it lines up with x equals 4 and y equals 8. And we remember that our x values are the number of plates that Lindsay makes, and our y values are the number of pounds. So what this would mean is that when it takes her 8 pounds of clay, because that's our y value. So what does the 4, 8 represent? It represents the fact that it takes 8 pounds of clay to make 4 plates. And that kind of makes sense, doesn't it? If the constant proportionality is 2, that means that whatever the number of plates she makes, you would multiply that times 2, and that's how many pounds it would take her to make those plates. So then, by the same token, if she makes 5 plates, which you can see right here, 5 plates lines up with the 10 pounds. So 5 times 2 is 10. So anywhere we would look on this graph, if she makes 3 plates, it should be 6 pounds, shouldn't it? So, and yes, that does line up with 6 on that y-axis. So anything we looked at down here, we should be multiplying it times 2. So we don't have where it lines up with that 6, but we know it would be 12, because 6 times 2 is 12. All right, let's move on and look at another one. Okay, it says this graph represents the serving sizes of chow mein at a local restaurant? Okay, so down on the bottom, we have the number of servings. And then over here on the left, we have the serving size in grams. So let's look for our constant of proportionality. Let me circle this in blue. Okay, so let's just say X equals the number of servings and Y equals how many grams is in that serving. So what I can see here is I've got, several points here. Let's look at this one all the way at the top here, right here. Okay, so this would represent on the y-axis 1,750 grams and on the x-axis 7 servings. So 7 servings is 1,750 grams. All right. What I want to look for is, let's see, which of these describes the meaning of the point 0, 0 on the graph. Let's look for that constant of proportionality first. I want to know how many grams is in one serving, and it would be 250. So that constant of proportionality would equal 250. It didn't ask me that. I just wanted to point that out again. Which of these describes, what describes the meaning? There was a multiple choice here, I think, on the original problem. But what does 0, 0 mean on the graph? Well, that means 0 servings contains 0 grams. So 0 servings would be 0 grams. And this is a proportional relationship, again, because it does go through this 0, 0 point, and it's a straight line. And we're going to look at that in the next video. All right, let's look at this one. Mr. Craig drew a graph to represent the number of wing nuts used in office chair assembly. The 0.15 on the graph indicates, and notice that these over here on the left, they count by fives. So this right here would be 5, 10, 15, 20, 25, and so on. And then these count by ones. So this is the 1 right here. So the 1, 5 right here on this graph would indicate that one chair takes 5 wing nuts to build. That is also the constant of proportionality. 4 chairs takes 20. 6 chairs takes 30. So just multiply that number by 5 and you'll get the number of wing nuts, of course, that it takes to build the chair. Okay, I think this is the last one we have. This is kind of hard to see. In a flash of sheer brilliance, Gary invents a time machine. The machine uses a small nuclear reactor to generate the electricity it needs to travel back in time. To travel back 5 years, Gary's time machine needs 3 megawatts of electricity. To travel back 10 years, he needs 6 megawatts. Okay, so let's look. Let's just make a little note here. To travel 5 years takes 3 megawatts. 5 years takes 3, we'll just abbreviate that, megawatts. And then 10 years is 6 megawatts. Just want to look at what we've been given. That's what we do in math. In this relationship, X represents how many years Gary wants to travel back in time. And X represents, and Y represents how much electricity the time machine needs. Graph 2 points for this relationship and the line passing through them. Well, we have years. These are the X values. The megawatts are the Y values. So these are two ordered pairs right here. X is 5, Y is 3. And then the other one is X is 10, Y is 6. So let's just graph those 2 points. 5, 3 is here. And 10, 6 is here. And then I'm going to grab my line tool. I have a line tool over here if I can find it. There we go. Okay. This is kind of hard with this line tool. Okay. Now let's look. Does it look like this would go through the origin? Yep, it does. And that kind of makes sense, doesn't it? 0 years would be 0 megawatts. That would make sense. So this is a proportional relationship also. And that's all I have for this video. So in the next video, we will be actually identifying proportional relationships. We'll look at tables and equations and graphs and ask ourselves, is this a proportional relationship?